In 1997, inside a factory in Boucherville, Quebec, Simaudio made an industrial decision that defied the entire North American hi-fi market. While competing brands were quietly moving production overseas and replacing heavy chassis with thin stamped steel to fight off a flood of cheap surround sound receivers, the Quebec manufacturer chose the opposite. They decided to machine massive blocks of solid aluminum. They engineered thick, oversized faceplates and wound heavy power transformers locally, driving their manufacturing costs upward. It meant local hi-fi dealers would have to sell a massive, unyielding machine to a consumer market increasingly obsessed with cheap convenience. The paradox is that Simaudio did not survive despite this extreme mechanical cost. They survived exactly because of it. This is not just the story of an amplifier. It is the story of a Canadian audio brand that refused to outsource its soul. The heavy faceplate that emerged from the Quebec factory was designed to block electrical interference, but it also served another purpose. It was a physical barrier erected against the global race to the bottom. Every week, we tell the stories of Canadian speakers, amplifiers, audio brands, and listening rooms that once shaped how people heard music and what happened when the market moved on. Subscribe if that history matters to you. The story begins not with nostalgia, but with a specific problem in a Quebec suburb in 1980. In 1980, the Canadian hi-fi market was entering a golden age of loudspeaker design, but it was hiding a fundamental electrical problem. Across the country, laboratories tied to the National Research Council were helping local engineers build incredibly accurate speakers. But an accurate speaker is often a difficult speaker to drive. To get a flat frequency response, how evenly a speaker reproduces low, middle, and high sounds, designers often built complex crossovers. A crossover, an electrical network inside a speaker that sends bass, mid-range, and treble to the drivers designed to handle them, can soak up a massive amount of electrical energy. This created a crisis in Canadian basement rec rooms and listening spaces. A listener would buy a precise, domestically made speaker, bring it home, and connect it to a mass-market receiver from a Japanese electronics giant. A receiver, an amplifier with a radio tuner and source controls built into the same unit, often looked impressive on a retail shelf, flashing with lights and buttons. But when the volume went up, the sound would thin out, become harsh, or the receiver would simply trigger its protection circuits and shut off. The issue was impedance, the electrical load a speaker presents to an amplifier. When a speaker's impedance drops during a deep bass note, the amplifier must instantly supply more electrical current. Most affordable imported receivers lacked the heavy internal power supplies to deliver that current. If a Canadian buyer wanted an amplifier that could truly control their new speakers, they had to spend a fortune on high-end American or British imports. There was a vacuum in the domestic market for pure, unyielding electrical power. Victor SEMA, a passionate audio designer based in the Montreal suburb of Saint-Hubert, Quebec, saw this gap. He understood that a high-fidelity amplifier, an electronic device that increases a weak audio signal so it can drive speakers, did not need a dozen equalization sliders or a digital display. It needed a massive heart. In 1980, he founded SEMA Electronics with a singular philosophy: put the manufacturing budget into the power supply, not the front panel. The result was the SEMA 2400. It was an integrated amplifier, a unit that combines both a control preamp and a power amp into one chassis. Visually, it was almost brutally minimalist. It was a stark black box with simple knobs and a red LED indicator. But when a customer picked it up, the physical weight told the real story. Inside the chassis, SEMA had installed an oversized transformer, an electrical part that changes voltage and supplies the raw power needed for the audio signal. He paired this with massive capacitors that stored energy like reservoirs, ready to dump current into the speaker the exact moment a kick drum was struck on the recording. To manage the intense heat generated by this constant flow of high current, SEMA utilized heavy external heat sinks, metal fins bolted to the chassis that draw heat away from the sensitive internal electronic components. It was overbuilt by design. It was a Quebec-made electrical sledgehammer designed to crack the impedance problem. The true test of the SEMA 2400 did not happen in a laboratory. It happened on the carpeted floors of Montreal hi-fi dealers. In the early 1980s, stereo shops were the ultimate proving ground. A customer could walk in, point to the most notoriously difficult, power-hungry speaker in the showroom, and ask the dealer to play it loud. When dealers connected the SEMA 2400 to massive floor-standing cabinets or exotic panel speakers that usually brought budget amplifiers to their knees, something unusual happened. The SEMA did not distort. Distortion, unwanted change or harshness added to the sound by an amplifier running out of power, was remarkably absent. More importantly, the amplifier did not shut down. The Montreal dealers realized they had a unique tool on their shelves. They could confidently sell high-end, demanding speakers to a local buyer, knowing they could bundle it with a locally made SEMA amplifier that would not fail. The amplifier simply got warm to the touch, its aluminum heat sinks silently doing their job, while the woofers, the large drivers designed to reproduce low frequencies, moved real air in the room. The kick drum felt physical. The stereo image, the illusion that sounds come from places between and around the two speakers, remained stable and wide, never collapsing when the music became complex. Building an amplifier this way was a severe economic risk. During the 1980s, Canada faced high inflation and mounting manufacturing pressures. SEMA Electronics was competing in a retail environment flooded with the legendary British-designed NAD 3020, which dominated the budget audiophile sector, alongside massive Japanese conglomerates that could manufacture thousands of circuit boards an hour. Every SEMA amplifier required expensive, heavy parts and skilled local labor in Quebec. Copper, steel, and aluminum were subject to shifting domestic costs. Yet SEMA refused to hollow out the chassis to save money. By staying heavy, the brand quietly built a fiercely loyal following. In Montreal living rooms, Toronto apartments, and Ottawa basement rec rooms, a SEMA amplifier became a lifelong purchase. It was the kind of industrial object that survived estate sales and was passed down to the next generation, often requiring nothing more than a simple recapping, the process of replacing old internal capacitors to restore original electronic performance to run for another 2 decades. But by the late 1980s, the hi-fi landscape was changing. Compact disc players were introducing a new level of digital clarity that demanded even quieter, more refined amplification. The brute force of the SEMA 2400 had established a loyal base, but the brand remained largely a Canadian secret. SEMA had proven that Quebec could build an amplifier that handled difficult speaker loads, but as the founder prepared to step away, the company faced a larger question of how to scale that reputation without losing its mass. By 1988, the hi-fi landscape was shifting beneath the feet of Canadian manufacturers. The compact disc had fully arrived, and with it came a ruthless new transparency. Digital audio had a silent background and a massive dynamic range that mercilessly exposed the flaws in average amplification. A powerful amplifier was no longer enough. It had to be incredibly quiet and exceptionally fast. At this critical juncture, Victor SEMA chose to step away, and the company was purchased by Jean Poulin, an audiophile and visionary who understood that the brand could not survive on brute force alone. SEMA Electronics was about to undergo a metamorphosis. It was time to leave the utilitarian black boxes behind. The company needed to move from the basement rec room to the dedicated high-end listening room, competing directly with the luxury brands of Switzerland and the United States. The first step was a radical visual departure, introduced under a new brand name, Celeste. Up until that point, high-end amplifiers were almost universally sharp, rectangular objects with aggressive, industrial cooling fins. The Celeste design, dubbed the Renaissance chassis, abandoned this entirely. The new amplifiers featured smooth, rounded, cylindrical corner pillars. The heat sinks, the metal structures required to dissipate internal heat, were integrated into a flowing, curved aesthetic. It looked like an architectural sculpture. It was a polarizing design that immediately caught the attention of hi-fi dealers, but the true breakthrough was not on the outside. The real revolution was buried deep inside the aluminum chassis, driven by a highly controversial engineering philosophy. The Celeste engineers committed to a circuit design that used zero global feedback. To understand why this was dangerous, one must understand how most of the audio industry operated. Global feedback, an electrical design choice where a portion of the amplifier's output signal is looped back to the input to correct errors and reduce measured distortion, was the industry's magic trick. By using a feedback loop, a massive electronics corporation could use cheap, loosely toleranced parts and rely on the circuit's self-correction to produce spectacular test measurements on paper. It was a highly cost-effective way to build a receiver. But there was a sonic penalty. Many critical listeners and Canadian speaker designers noted that while heavy global feedback looked perfect on an oscilloscope, it often made music sound sterile, slow, or artificially constrained. The feedback loop, reacting to an error that had already happened, could smear the delicate timing of an acoustic guitar or the decay of a cymbal. By choosing zero global feedback, the engineers at the Boucherville plant threw away the safety net. Without a feedback loop to automatically clean up mistakes, the amplifier circuit had to be perfect from the moment the signal entered until the moment it left. This meant the company could no longer buy standard, off-the-shelf components. The margin for error dropped to zero. This decision exposed the company to one of the most frustrating challenges in solid-state audio: crossover distortion. Crossover distortion, an unnatural harshness that occurs precisely at the 0 point when an audio signal transitions between the positive and negative output transistors, is the enemy of natural sound. In a cheap amplifier, global feedback hides this harshness. In a zero feedback amplifier, it is painfully obvious. The only way to eliminate crossover distortion without using global feedback was to use transistors that were mathematically and electrically identical. But transistors are physical objects, and no two are manufactured exactly the same. This reality forced the Quebec factory to adopt a painstaking, brutally expensive manufacturing process. Technicians on the Boucherville assembly line had to manually measure and test bins of transistors. They would measure the electrical characteristics of hundreds of individual parts, searching for the rare, perfectly matched pairs. A massive percentage of the parts they bought could not be used in the critical audio path. This was the exact opposite of modern, efficient manufacturing. It drove the cost of labor and materials incredibly high. While other brands were streamlining their supply chains to compete in big-box retail stores, the Celeste amplifiers were being built with the slow, meticulous pace of a watchmaker. When the first Celeste amplifiers arrived at hi-fi dealers in Toronto, Montreal, and Vancouver, there was intense hesitation. The dealers looked at the radical curves and the high price tags. The Canadian audio market was notoriously practical, and the Celeste line was demanding a premium price usually reserved for elite imports. But then the dealers wired the Celeste amplifiers to premium speakers and pressed play on a CD transport. The sound was a revelation. Because the amplifier did not use global feedback, there was no electronic delay, no smearing of the signal. The amplifier was astonishingly fast. It gripped the woofer tightly during complex bass passages and let the tweeter breathe without a trace of artificial glare. The soundstage, the perceived width, depth, and placement of music created by a stereo system, snapped into holographic focus. The music possessed a natural, unforced rhythm that heavily corrected mass-market receivers simply could not replicate. Word began to spread through the Canadian hi-fi community. Reviewers took note. The Celeste amplifiers measured differently, but they sounded undeniably real. The risk had paid off. Jean Poulin and his engineering team had successfully elevated the company from a regional problem solver to a national high-end contender. They had proven that a zero-feedback design could be manufactured, provided a company was willing to absorb the extreme cost of doing it right. But that very success created a new pressure. The brand was growing, the expectations were rising, and the global market was watching. The radical curves of the Celeste amplifiers proved that Simaudio was no longer content with being a local secret. They were ready to build a visual and technical moat. By 1997, Simaudio had perfected the zero-feedback circuit, but the global audio market was rapidly stratifying. The middle tier of hi-fi was being hollowed out by plastic home theater packages. To survive, Jean Poulin and the Boucherville engineers realized they could not simply compete. They had to overwhelm. They retired the Celeste name and launched a new flagship tier designed to compete with the absolute highest echelons of American and Swiss audio. They called it Moon. The first products to carry this badge, the Moon P5 preamp and the W5 power amp, were an exercise in mechanical and electrical extremism. Simaudio abandoned the graceful curves of the Celeste era for an imposing architectural aesthetic. The new faceplates were machined from thick, aircraft-grade aluminum billets, anodized in a striking two-tone black and silver. But the visual intimidation was only a byproduct of the engineering inside. The W5 power amp, an amplifier stage that provides the current and voltage needed to move speaker drivers, weighed over 70 pounds. A significant portion of that weight came from massive, custom-wound toroidal transformers. A toroidal transformer, a donut-shaped electrical component that steps down wall voltage while maintaining a massive magnetic field, was incredibly expensive to source and manufacture locally in Quebec. Simaudio used two of them in a true dual mono configuration. Dual mono, a design where the left and right audio channels operate as completely independent electrical circuits sharing nothing but a single power cord, ensured that a heavy bass impact on the left channel could never steal power or smear detail from the delicate treble on the right channel. To support these transformers, the Boucherville assembly line packed the chassis with arrays of oversized capacitors, giving the amplifier immense energy reserves. A standard mass-market receiver might use a few thousand microfarads of capacitance to store energy. The Moon amplifiers used hundreds of thousands. When a listener triggered a sudden orchestral crescendo or an explosive kick drum, the amplifier did not draw instantly from the wall socket. It dumped current directly from these internal reservoirs, maintaining an iron grip on the woofer's voice coil. A voice coil, a coil of wire attached to the speaker cone that moves when electricity passes through it, requires absolute electrical control to start and stop without overhang. And the W5 delivered it flawlessly. The stakes were no longer just about proving that a Quebec factory could build a good amplifier. The stakes were about proving that domestic manufacturing could dominate the absolute pinnacle of the global luxury audio market. If these massive, incredibly expensive units failed to sell, the factory's immense capital investment in metalwork and raw materials would bankrupt the company. But they did not fail. The global high-end community, accustomed to dismissing Canadian electronics as purely utilitarian, was stunned by the Moon W5. The amplifier measured with surgical precision, yet it retained the fast, natural, uncompressed sound of a zero-feedback design. Almost overnight, heavy wooden crates stamped with the Simaudio logo began leaving the Boucherville loading docks, bound for the most demanding hi-fi dealers in the world. A Moon amplifier was no longer just a solution for a difficult Canadian loudspeaker. It became the centerpiece of the room. In upscale audio showrooms in Toronto and Vancouver, dealers proudly placed the P5 and W5 on dedicated isolation racks, often pairing them with flagship Canadian speakers from Paradigm or premium European imports. The brand quickly expanded its footprint, securing distribution in elite high-end boutiques in New York, commanding attention at the Munich High-End Audio Show in Germany, and earning rare, fiercely guarded respect from audiophile reviewers in Tokyo. During this peak cultural moment in the late 1990s and early 2000s, the Canadian basement rec room and the dedicated luxury listening room converged. An audiophile in Montreal would unbox a heavy Moon amplifier, slot it into a solid maple audio rack, and wire it to a pair of premium floor-standing speakers. When the blue standby light illuminated the brushed aluminum faceplate, "What space is I might get what space?" it represented more than just ready power. It was physical proof that a local factory could build an object of uncompromising permanence. The heat sinks would warm the room during the cold Quebec winter, and the holographic soundstage would expand far beyond the physical walls. Simaudio had successfully scaled their mechanical philosophy, proving that a market existed for extreme, locally manufactured electronics. But establishing a global footprint required a massive, continuous flow of capital. That first success did not solve the problem. It created a larger system that now had to be fed. The success of the massive W5 power amplifier proved that Simaudio could physically command a room, but the engineers in Boucherville understood a hard truth about high-end audio. An amplifier can only magnify what it is given. If the source signal is flawed, the massive power supply simply amplifies the flaw with perfect accuracy. By the early 2000s, the compact disc was the undisputed king of physical media, and Simaudio realized they needed to control the very beginning of the audio chain. They had to enter the digital arena. For most audio brands, building a CD player, a machine that reads a compact disc and turns its digital data into music, was a simple exercise in outsourcing. A company would purchase a pre-packaged plastic transport mechanism from a Japanese conglomerate, drop a standard decoding chip onto a basic circuit board, and wrap it in an attractive metal box. Simaudio completely rejected this approach. They decided to apply their extreme mechanical philosophy to digital playback, a project that would culminate in the flagship Moon Evolution series. The Boucherville engineers treated digital audio not just as a software problem, but as a severe physical challenge. They understood that a transport, the mechanical part of a CD player that spins and reads the disc, had to hold a rapidly spinning polycarbonate disc perfectly stable, while a microscopic laser read the data. Any physical vibration from the heavy bass of the loudspeakers in the listening room could vibrate the chassis, causing the laser to misread the disc and forcing the error correction software to guess the missing data. To prevent this, Simaudio designed proprietary mechanical suspension systems. They mounted the delicate laser mechanisms on heavy, decoupled sub-chassis. The disc drawer did not rattle or flex like a standard plastic tray. It was built from machined metal, gliding open and snapping shut with the heavy, cold precision of a bank vault. Once the laser successfully extracted the data, it had to be converted. A DAC, a digital-to-analog converter that turns digital data into an analog audio signal, is highly sensitive to microscopic timing errors. In the digital audio world, these timing errors are called jitter. Jitter smears the tiny temporal details in the music, making a digital recording sound harsh, brittle, or artificially bright. To fight jitter, Simaudio refused to rely on standard, off-the-shelf clocking circuits. They built dedicated, heavily shielded digital clocks and powered them with the same massive, oversized toroidal transformers they used in their power amplifiers. They physically separated the noisy digital processing boards from the delicate analog output stages, often placing them in entirely different chassis connected by custom umbilical cables. This level of over-engineering was a terrifying financial gamble. The research and development costs for proprietary digital audio were staggering. Simaudio was sinking millions of dollars into machining metal fortresses to protect digital signals, while cheaper competitors were simply updating software on imported boards. They were tying up immense amounts of capital in a technology category that threatened to become obsolete every 3 to 5 years. But the gamble worked, and it scaled the company to its absolute zenith. The Moon Evolution digital sources became the perfect required partners for their massive amplifiers. In a dedicated high-end listening room in Toronto, or a luxury dealer showroom in Chicago, a buyer could now assemble a complete, uncompromised Canadian audio ecosystem. They could place a heavy Moon CD transport on the top shelf of an isolation rack, run a digital cable to a separate Moon DAC, feed that pristine analog signal into a Moon preamp, and drive the music through a pair of 70-pound Moon mono blocks. This was the peak of Simaudio's mechanical era. A full stack of Evolution series electronics could easily cost as much as a luxury automobile. They had successfully built an ultra-high-end audio empire entirely within the borders of Quebec. The factory floor in Boucherville was operating at maximum capacity, shipping these heavy silver and black monoliths to specialized hi-fi dealers across North America, Europe, and Asia. They had secured their place at the very top of the global audio hierarchy, proving that a Canadian factory could produce a measurable, physical luxury. At its peak, Simaudio had achieved global recognition for its heavy, unyielding steel and aluminum sculptures, but the ground underneath the traditional high-end rack was about to shift. The first crack in the Canadian high-end audio empire did not happen on the factory floor in Boucherville. It happened behind the glass storefronts of retail showrooms. For decades, Simaudio had relied on a very specific, carefully controlled environment to sell its equipment: the independent hi-fi dealer. These were specialized stereo shops embedded in cities like Montreal, Toronto, Calgary, and Vancouver. They were staffed by salespeople who understood exactly how to demonstrate a high-current amplifier or a precision CD transport. When a customer walked into one of these carpeted listening rooms, the sheer physical presence of a Moon amplifier did half the selling. The heavy aluminum faceplate, the massive external heat sinks, the distinct mechanical click of its volume relay, these were physical proofs of value. But by the late 2000s, that retail ecosystem began to fracture. The consumer electronics market was undergoing a violent disruption. Big box retail chains began dominating the Canadian suburbs, pushing inexpensive, complete home theater-in-a-box packages. At the same time, online forums, review blogs, and early e-commerce platforms started replacing the trusted local salesperson. A new generation of customers would read an online review, search for the lowest possible price, and order a mass-market receiver directly to their door. The independent hi-fi dealer, with its high overhead and dedicated demonstration rooms, could not compete with warehouse pricing and online convenience. One by one, legendary audio showrooms across North America quietly closed their doors. Their leases expired. Their inventory was liquidated. For a company like Simaudio, this was a systemic catastrophe. You cannot easily sell a 70-pound, zero-feedback, dual mono amplifier through a low-resolution photograph on a website. It requires a physical demonstration. It requires a listener to sit in a chair and actually hear the holographic soundstage that justifies an extreme price tag. As the North American dealer network shrank, the heavy wooden crates leaving the Quebec factory had fewer and fewer places to go. This retail collapse was immediately compounded by a second, even more terrifying shift. The fundamental way people interacted with music was changing. The compact disc, the physical format that Simaudio had spent millions of dollars mastering with its flagship Evolution series, was rapidly losing ground. A new demographic of listeners did not want to buy or store physical media. They wanted digital convenience. They were downloading compressed audio files, organizing them on hard drives, and streaming them through early network devices. To an emerging audience of younger, affluent buyers, a massive, brilliantly engineered CD player was no longer an object of desire. It felt like an expensive anachronism. It was a beautiful, mechanical dinosaur. The traditional audiophile market was aging out, and the new market was rejecting the very concept of a dedicated, single-purpose listening room. They wanted music available instantly, in every room, controlled entirely from a glowing glass screen. These twin forces, the death of the independent hi-fi dealer and the rise of invisible digital files, crushed the traditional North American audio industry. The economic pressure on domestic manufacturing became unbearable. Across the border in the United States, and right within Canada's own borders, the high-end audio sector fractured. Venerable amplifier and speaker brands realized they could no longer sustain the cost of local labor, custom circuit boards, and heavy metal chassis. To survive the retail shift, they surrendered. Company after company filed for bankruptcy or sold their naming rights to private equity firms. Those global holding groups immediately stripped the manufacturing out of North America. They closed domestic factories. They let local engineers go. They outsourced production to massive assembly plants in Asia. They kept the prestigious Canadian or American badges on the front of the equipment, but the electronics inside were now standardized, cost-reduced, and driven entirely by global supply chains. A brand name that once guaranteed local craftsmanship became nothing more than a marketing asset in a corporate portfolio. Simaudio was caught in a brutal vice. They were still operating a massive, power-hungry facility in Boucherville. They were still employing highly skilled Quebec technicians to manually measure and match transistors. They were still buying raw aluminum, copper, and steel at premium domestic prices. The shipping costs alone for a heavy amplifier were skyrocketing. Every piece of modern financial logic dictated that they should follow their competitors. They should move the factory offshore. They should switch to cheap stamped metal. They should adopt standard global feedback circuits to save money. They should license the Moon badge to a line of plastic Bluetooth speakers, portable, Lotsky Khans, multiple Voldu portable wireless cylinders designed to connect to smartphones, to capture the new market. But the company refused. They believed that if they compromised the physical and electrical integrity of the Moon brand, they would lose the only thing that made them valuable. They dug in. They kept the factory open. They kept pouring money into the heavy, uncompromising machines that defined them. But the balance sheets were under severe threat. The old world of hi-fi was gone. The independent dealers were vanishing. The silver discs were dying. The massive amplifiers were still perfect. But the living room around them had changed. The factory was still standing, but the walls were closing in. The company needed a lifeline. They had to find a way to make their heavy metal speak a new language. Simaudio realized that holding on to the past was a slow death sentence. By 2013, a reorganized leadership team, driven by executives who understood the shifting digital winds, took full control of the company. They understood that the heavy metal chassis was their core identity, but the signal path flowing through it had to drastically change. The compact disc player was no longer the undisputed center of the audio rack. The streamer, a network audio device that receives music from online services or local files, was rapidly becoming the primary source for a new generation of high-end listeners. Building a streamer is fundamentally different from building an amplifier. An amplifier is a physical puzzle. It is a battle of transformers, heat sinks, and raw electrical current. A streamer, however, is a problem of mathematics and software. This created a terrifying bottleneck for traditional audio manufacturers. Most heritage hi-fi companies panicked. They possessed decades of knowledge about analog circuitry, but they knew nothing about writing code. To survive, many of Simaudio's competitors simply bought off-the-shelf software modules from third-party technology companies, slapped those generic boards inside their metal boxes, and released their own branded apps. The results were often disastrous. The hi-fi industry became littered with heritage audio brands that produced brilliant-sounding hardware crippled by obscene, unstable, frustrating network software. When an app crashed during a listening session, The buyer did not blame their local Wi-Fi router. They blamed the massive, expensive amplifier sitting in their living room. Simaudio refused to take that risk. They understood that outsourcing the software meant outsourcing the entire user experience. Instead, they decided to build their own proprietary streaming ecosystem from the ground up, entirely within Quebec. They called it the Moon Intelligent Network Device, or MIND-D. This was an agonizingly expensive and culturally shocking pivot. The Boucherville factory, historically built to handle heavy copper, soldering irons, and aluminum billets, now had to integrate a software development team. They had to write proprietary code, design fluid user interfaces, and ensure their heavy metal machines could talk flawlessly to smartphones, tablets, and cloud-based high-resolution streaming servers. The introduction of the MIND-D platform changed the fundamental nature of what a Moon product was. An amplifier was no longer a static, finished object the moment it was placed into a wooden shipping crate. It was now a living, upgradable digital system. It could receive firmware updates over the internet, adapting to new streaming services and digital formats long after it had left the dealer's shelf. At the same time, the physical footprint of the Canadian listening room was shrinking. The sprawling 5-box audio system that dominated the 1990s was losing its appeal in modern urban homes. The market wanted intense integration. Simaudio responded by merging their heavy Class A-B amplification, a circuit design that blends the sonic purity of high-heat Class A power with the operating efficiency of Class B, with their proprietary DAC technology and the new MIND-D streaming platform. They packed this entire ecosystem into single, unified chassis designs. These all-in-one streaming amplifiers retained the thick aluminum faceplates, the massive toroidal transformers, and the zero global feedback circuits that defined the brand. But they eliminated the need for complex racks of external cables. A listener in a downtown Toronto condo or a modern Vancouver apartment no longer needed a massive, dedicated equipment rack. They could place a single Moon integrated streaming amplifier on a credenza, wire it to a pair of premium Canadian bookshelf speakers, and access every high-resolution album ever recorded, controlled entirely by a glass screen in the palm of their hand. The physical footprint of the system shrank, but the heavy, unyielding power of the Boucherville factory remained intact. It was a brutal, high-stakes balancing act. If the software failed, the hardware was useless. If the hardware lost its mechanical weight, the Moon badge lost its prestige. The factory had to straddle two completely different manufacturing realities simultaneously. They had to preserve the extreme, old-world mechanical craftsmanship while mastering the invisible, fast-moving world of network code. As they navigated the end of the decade, the pressure on the global audio industry only intensified. The old hi-fi retail world was collapsing. Independent dealers vanished from main streets. Competitors sold their names to the highest bidder. Private equity firms gutted rival brands. Production moved offshore. Circuits became cheap. Chassis became thin. The physical weight of the audio industry disappeared. But Simaudio did not run. They stayed in Quebec. They milled the metal. They wound the copper. They wrote the code. The Quebec factory was still humming, but the machines inside were no longer just bending heavy aluminum. They were writing code to survive the new world. Simaudio MOON did not collapse. Unlike dozens of revered North American audio brands that surrendered their manufacturing independence and became mere portfolio logos stamped onto imported plastic, the Quebec house survived. They survived by forcing their uncompromising heavy metal hardware to speak the fluid language of the modern internet. Today, Simaudio remains one of the very few high-end audio manufacturers that still fully designs, machines, assembles, and tests its equipment strictly within Canadian borders. If you walk onto the factory floor in Boucherville today, you will witness a surreal intersection of listening eras. In one sector of the building, the scene looks exactly as it did in 1997. Local technicians sit at specialized amplifier benches, using soldering irons to manually assemble massive toroidal transformers and carefully bolting heavy, anodized aluminum faceplates to rigid metal chassis. In another sector, seated in quiet offices, software engineers type lines of code, constantly refining the mind network architecture to ensure that a massive Class A/B amplifier can instantly lock onto a high-resolution audio stream from a server halfway across the world. The sheer physical weight of the past operates perfectly alongside the invisible digital demands of the present. Out in the wider Canadian listening landscape, the early chapters of this story refuse to vanish. On the digital classifieds of Kijiji, and within the dedicated enthusiast forums of Canuck Audio Mart, original SEMA electronics and Celeste components remain fiercely guarded objects. A vintage SEMA 2400 integrated amplifier from the early 1980s, or a curved Celeste power amp from the 1990s, rarely stays listed for long. To the vintage audio collector and the budget-conscious audiophile, these are not obsolete electronics. They are highly sought-after industrial-grade tools. A music lover building a system in an Ottawa basement rec room will happily purchase a 30-year-old Simaudio piece, knowing exactly what they are getting. They buy it because that uncompromising, zero global feedback circuit still grips a woofer tighter, reacts faster, and projects a more holographic soundstage than almost any heavily corrected modern mass-market receiver in the same price bracket. The original acoustic promise remains completely intact. This enduring secondary market reveals one of the most remarkable footnotes in the Canadian audio industry. If a listener purchases a battered original SEMA amplifier from an estate sale or a thrift store shelf, an amplifier engineered and sold before the compact disc was even a mainstream format, they do not have to cross their fingers and hope it holds together. They can pack that heavy black box into a shipping crate and send it right back to the factory in Boucherville. Simaudio still maintains the original schematics, the specialized testing equipment, and the dedicated expertise to repair, recap, and restore those foundational units. The company does not force the vintage owner into a mandatory upgrade cycle. They actively honor their original mechanical promise. This is why the extreme heavy metal era of Simaudio still matters today. The original models prove the absolute value of long-term repairability in a culture obsessed with replacement. In the broader consumer electronics market, the listening habit has shifted toward disposable convenience. A soundbar, a wide multi-speaker enclosure designed to sit under a television and replace a traditional stereo pair, or a portable Bluetooth speaker, is almost entirely unrepairable. When the internal battery degrades or a cheap processing chip fails, the entire unit becomes electronic waste. A Simaudio amplifier represents the exact opposite philosophy. Because the company utilized a modular internal architecture and vastly overbuilt its internal components, the machine was designed to outlast its original owner. A degraded capacitor can be cleanly desoldered and replaced. The massive aluminum heat sinks will never crack or warp. A high-current amplifier can drive a newly refoamed pair of Canadian speakers that have had the flexible ring around their woofers freshly replaced, for another 3 decades without breaking a sweat. The company understood early on that a true luxury object is not defined strictly by its price tag. It is defined by its absolute refusal to be thrown away. The story of Simaudio MOON is ultimately a total rejection of standard manufacturing logic. Every global economic force over the last 40 years dictated that they should make their products lighter, cheaper, and entirely reliant on foreign assembly lines. They were told repeatedly that the independent hi-fi dealer room was dead, that physical media was finished, and that nobody would pay a premium for a massive aluminum faceplate in the frictionless age of the smartphone. But the Boucherville factory proved that high-end audio is not simply an exercise in nostalgia. It is about a fundamental, unyielding respect for physical craftsmanship. It is the belief that an object built to survive the harshest electrical impedance drops can also survive the harshest retail market shifts, provided the company refuses to compromise the foundation. Somewhere in a sunlit Montreal listening room, a heavy silver and black amplifier sits quietly on a maple rack, its blue standby light glowing in the dark, ready to sweep the cold Quebec winter away with the first note of a spin. Every week, we tell the stories of the Canadian audio empires that shaped how we listen. Subscribe to join us. See you in the next one.